So this topic covers the kinds of habitats you might find in Wisconsin and also a lot about the kind of inferences you can draw based on the numbers and abundances of species that you find in a habitat. So kind of in short, it's a way to characterize the habitat using an inventory of species that you find. So to get started, there is a catalog of natural community types that's been put together by folks at the DNR and other places. This is specific to the state. If you were in a different state or even in another country, you might have something like this for that region. Ecologists like to put the boundaries on communities and say we have one type or another type. And these largely are defined by the species that are found there. So if you are going through a habitat and you notice an abundance of one kind of species, it could be that's an indicator for the particular habitat type. So I have some links here to a couple of resources you might explore to learn more about the natural community types. And I'll walk you through those. It's a little hard to just present them to you, but you might be familiar with some of the ones that we'll talk about. So a natural community type, obviously community is made up of lots of species, but in ecology, we often find a dominant species, one or a few species that are really characteristic of the habitat. So dominant can take on a couple different meanings in ecology. One is just the most abundant. So if you're in a grassland and there's a particular species of grass that you see a lot of, you could describe that as a dominant species. Same with a forest. The overstory trees that make up a forest will have probably a few of the tree species are the more abundant ones. Those can be viewed as the dominant species. Another interpretation of dominant is that some species have an influence over the character of the habitat. So going back, probably the forest is a better example to think about this. If you have a forest and the overstory is maple, for example, this is a deciduous tree, and having a deciduous tree is going to influence the relative amounts of light different times of year. And then sometimes trees, for example, something like a pine tree can influence the kinds of plants that can grow underneath it. So there's sometimes some shading and sometimes some chemical effects with the tree species, and they can kind of determine what other species grow there. And another reason for characterizing based on a few dominant species is that those can also have a big influence over the animals that visit an area. So if you have seeds that are being moved around by animals, birds, for example, or squirrels, if those are important in moving seeds around, then they're going to visit habitats of a certain type. And so the community type kind of feeds back on itself and reinforces the membership in the community. Plants that are adapted to grow together, plants that are adapted to grow with the same kind of animals that live in that habitat, and so on. So it's kind of a good basis for a much bigger concept. Um, but knowing really for the natural community types, if you look at that resource, just a few species are mentioned as these major indicators of the habitat type. And they're kind of a stand-in for the rest of the diversity that you might be able to find there. So looking at different habitat types, besides these dominant species, what are the other determinants, factors that might determine what kind of habitat you have? And it turns out there are just two really big ones that I would say would be the amount of tree cover that you've got. So we've got a range going from forests to prairie, forest fully covered by trees or mostly covered by trees, and prairie hardly covered by any trees or shrubs, mostly herbaceous plants. And then the other big determinant, kind of inferred by this illustration here, um, would be soil water abundance. So different amounts of water in the soil can really influence the greater community that's put together. So I'll kind of go through a few of these just to mention them. I'll show you some images of the plants that would be found in these habitats, but really to get a good long-term appreciation for these, you probably want to get some experience going to these different habitat types. Some people view them as like a checklist, right? If you want to learn all the different habitats in the state, and if you want to stand the best chance of seeing all the species, all the plant species in the state. and you would try to visit all these different community types. So first up is the fully aquatic habitat. You can maybe guess what the influencing factor is that defines our fully aquatic habitat. So this is one that's got standing water, basically standing water year round, often open bodies of water, a lake, a pond. And uh, the plants that grow there, they take advantage of abundant water, but then they also have some challenges. So growing in the water can be limiting for allowing oxygen to get down to the roots, or if you have a plant that's growing completely underwater, it has difficult time getting gas exchanged. So processes that need air usually in plants are photosynthesis, needs carbon dioxide, cellular respiration needs oxygen. And for terrestrial plants, all parts of the plant are able to access air basically. So roots, for example, might be doing some cellular respiration. And that's a bit of a challenge if you're living in an aquatic habitat. So uh, we do find characteristic plants that are adapted to those conditions and thrive and are able to compete well in that environment. So just some illustrations of the plants you might find in these fully aquatic habitats. This is a community of plants that are present underwater. So this is what we call the submergent aquatic community. So plants that are submerged or submersed underwater. And a lot of them, they're adapted definitely to growing in the water, and a lot of them still have above water pollination. So this pondweed here is getting its flowers pollinated above the water, this milfoil above water, waterweed above water, bladderwort has flowers above water. A few of them are pollinated underwater. So Nias ceratophyllum have underwater pollination, Vallisneria pollinates at the water surface. And then one you might run into, this is an algae, so no pollination, but does have reproduction underwater. So underwater community, now the emergent community. So these are plants with their roots in the water, but able to grow upright out of the water. Again, still putting up with that challenge, mostly because they have a difficult time getting air to their roots to do cellular respiration. So they have to kind of have an adaptation to deal with that. And usually you'd find these on a lake edge or something like that. And just some example plants here, some you're probably familiar with, cattails. Related to cattails are the burr reeds, soft stem bulrush, sometimes a rather tall plant here, arrowheads and sedges, just to name a few. So those were our aquatic habitats. There's not really, apart from a swamp, which we don't have too many in Wisconsin, there's not really tree cover on these aquatic habitats. So moving over to tree cover, we can consider these more terrestrial habitats, going in a range from mostly covered by trees, so mostly shaded out. Those qualify as forest, rather familiar term for you probably. Areas that have trees, but not a lot of tree cover, less than 50%, those classify as a savanna. So a lot of light penetration to the ground level, and so the herbaceous plants can be a little better access to light there. And then prairie counts as habitat that has less than 50% cover. So some of these forests, we'll just go through the forest habitats. They're classified now, so we classify them already by light availability, and now moving on to soil conditions. So the southern dry forest, name pretty descriptive there. So basically dry soil in a terrestrial environment, but also with tree cover. You can see on the map here, one of the resources I gave you a link to, you can get a map of the state that shows you where and what counties you would find these kinds of habitats. So naturally a little more southern distribution for the southern dry forest. These are some characteristic species. So oaks, black cherry, gray dogwood, and understory herb here, the false Solomon seal, to name a few. Mesic forest. Mesic is a term meaning kind of middle of the road for soil, not too wet, not too dry. Also a southern feature, southern mesic forest, and these are our southern mesic forest trees. Lindens, maples, a little bit more than the oaks that we saw in the other forest type. Beech is kind of limited a little bit more to the eastern part of the state. Floodplain forest, as you might, its name doesn't say wet, but you can kind of get it from the name there, floodplain. So a floodplain is during times of year when there's high water levels, a lot of times pretty regularly in the spring sometimes. This area would be covered by water, and then at other times of the year it is drained. So just in general, it's got some pretty abundant soil moisture. And this image, I kind of like this image. You can see on here, there's a kind of a staining on the tree trunks where the high water level was from previous flooding. So this is an area that's adapted for that condition to happen. Floodplain is kind of a low elevation area next to a river, for example, and gets flooded uh, basically every year. And some trees and other plants that go along with that, hackberry, green ash, silver maple, some shrub here, button bush, river birch, and then an herbaceous wood nettle. All right, so moving over to the savanna amount of light coverage. So the oak opening is one that we have kind of a lot local to us near Whitewater. This is basically a grassland habitat that also has, as the name shows, oaks. We have some oaks that are adapted to this habitat. This is one that's historically and prehistorically influenced more by fire. So trees that are adapted to relatively frequent burnings, including the bur oak is a pretty common member here. There it is, bur oak, also our shagbark hickory in the oak opening habitat. Dry prairie, as the name implies there, pretty dry, mostly southern. And a lot of our prairie habitats, we're going to be looking at the graminoids to define those. So grasses and sedges are big determinants of the prairie habitat. These are some example grass species you might find in the dry prairie. Mesic prairie, similar distribution. And also again, some practice will probably get you more familiar with these kinds of species. So if you know them, you might already be picturing a mesic prairie habitat. Or if you're not familiar with these grass species, they might be some that you run into, maybe a little bit more than other grass species, depending on what habitat you're visiting. And then wet prairie kind of shifts over a little bit more to favoring maybe a sedge habitat, but also a few of these grasses in here. So just mentioned a few with their names. So looking at the community types, there's a concept in ecology called succession, where basically we're referring to a habitat type that's not always constant. And it's possible for one habitat type to change into another. Sometimes this is viewed as a kind of an eventual result of plants growing up. So for example, if you start with an area that's been burned and the trees and the herbaceous plants are all basically killed down to ground level, the things that come back are going to be the herbaceous plants first, some shrubs a little bit later, and it takes a while to build a forest kind of habitat like this. So a lot of times you might see a habitat that's in the process of going from prairie toward forest. Um, it's not always, though, necessarily the case that your prairie is destined to become a forest. So there are factors that can prevent forests from establishing. So soil conditions and fire, as I mentioned, that can be a deterrent to trees getting established. So as far as enabling succession, this is something that sometimes happens as a result of changing, a lot of times these days, with management strategies. So if humans are involved and humans are no longer burning the habitat, for example, then trees and shrubs can take over and enable some succession. Herbivory, so animals grazing, these are things that before European settlement, fires were pretty prevalent. Grazing was maybe a little more of a pressure, say something like bison ancestrally. And then in the absence of those pressures that kept the prairie in place, the forest moves in a little bit more. So you often see an illustration like this process of succession. Um, Sometimes it's initiated as a result of disturbance. So as I mentioned, potentially a fire comes through and burns most of the above ground vegetation. That can kind of clean the slate for the habitat. And the first plants that come in are the ones that are able to get there first. So these plants called so-called pioneer species, these are often ones that are good at dispersing. So maybe abundant seed production, seeds that get around without animal help. So seeds that fly on the wind or something like that. And then also plants that are able, once their seeds get to a location, plants that are able to make an existence there without necessarily a lot of other plants around. So it's a particular kind of species that can be one of these pioneer species and get established where there isn't much of a community. There's not a diverse plant habitat yet. Might be missing some animal associations or some plant or fungal interactions that are necessary. And those pioneer species are able to take advantage of that a little bit more. Generally speaking, going from the disturbed clean slate habitat over on the left to the what's sometimes called the climax community, the most uh, kind of the most established habitat, there often is an increase in diversity as this scale moves over in time. So you can think of the diversity establishing as certainly the first species that get there. There are not that many species that get there initially, but the existence of some species can enable other ones to show up. So as I mentioned, animals bringing seeds in, if you've got bird habitat and birds bring seeds in, uh, other animals might be dispersing seeds into that habitat. That allows them to get established because there already are plant species there. There also can be ecological cooperation. So some plants thrive in shade, sometimes full shade, sometimes partial shade. And so they might need the overstory of trees to get them going. Take some time to get the larger trees established and kind of open up the understory in some cases. And so there are herbaceous plants that grow under trees in the forest, but really under established trees. So generally speaking, these longer established habitats have greater diversity because there's been more time for species to move in and work with each other. So as far as getting to the diversity, we can measure the diversity or get some estimates of diversity. And this is something we'll have you do for the project for this course, is to try and put a number on diversity. So it's easy to maybe look at a habitat and take a list of all the species that are there and say, okay, this is diverse. But sometimes you want a little bit more of a quantitative measurement for how diverse the habitat is. So there are lots of different ways to look at diversity. One simple way is, before we get into this equation here, one simple way to estimate diversity is just to count the number of species. So it's the most basic version of diversity. How many species in the same area? If you take an equivalent area in one habitat or another habitat, the one that's got more species in that area is more diverse. This slide is showing an equation for something you might have used before, which is a diversity index called the Shannon Diversity Index. And it's got an equation there. The equation might be a little daunting, but we can walk through it. And this basically is an equation to estimate diversity based on the relative abundances of a certain number of species in the habitat. So uh, we'll do one of these in a following slide, but one of the operative measurements here is this P sub I. This is proportion of the total number of individuals that are a given species. So you calculate this value for each of the species that you find in your habitat, and then this big capital sigma character tells you that you take a sum of all those values for every species that you've got. So we'll do one of those. You'll get a chance to do it on your own. The one of the measurements you can get also as a result of this is called the effective number of species. And you get that once you've calculated the Shannon index, which is just called H prime. The effective number of species is the number E. So that's the numerical constant E raised to the h prime. And to do that measurement, that gets you something we call the effective number of species, which is more or less kind of, you could interpret that if all species were equally abundant, this would be kind of the number of species you would have in that habitat. So uh, in a habitat, not every species is represented to the same abundance, and that's totally normal. Um, and this number kind of levels the playing field on that. So in this class, we're just going to get these numbers and compare them. Say you surveyed 2 habitats and you had a higher diversity index for one habitat. That would be maybe something to favor that habitat if you were deciding between 2 places to spend your conservation efforts or something like that. So here's an example. These are some species with their relative abundances. This would be maybe the kind of data you would get from doing one of those quadrats for surveying. And so these are abundances rounded or estimated to one significant digit. So numbers in between 1 and 10 are exact. Numbers between 10 and 100 are estimated to the nearest 10, and numbers between 100 and 1,000 estimated to the nearest 100. So this is it's not a precise tally here, but it's definitely pretty good for this kind of estimate. So total 791 species. This P sub I is achieved by taking each abundance and dividing it by the total. So these species that have 2 individuals, that's one of the lowest, or that's the lowest number. This species is a grass species that has 600 individuals. That has the largest proportion value. So this is 0.75. About 3/4 of the plants in this habitat are this one species. And then the fancier equation here. So P sub I times the natural log, that's ln, natural log of P sub I. And then a sum of those, this value right here is the Shannon index value. And then taking that value, raising e to that power gets you 2.4 effective number of species. So again, not necessarily very meaningful on its own, but you could take these values and compare them between 2 habitat surveys, 2 plots, and see how they compare to each other. Besides the diversity, you can also use some other features about plant species to help you understand your habitat. And one of them is what is called the wetland indicator status. So every plant has a range of habitats it might grow in. It might have a narrow range, it might have a broad range. If it has a narrow range of wetland tolerances, it might grow uh, only in wetlands. This value here, OBL, stands for obligate. And that's a plant that always grows in habitats that are classified as wetlands. This goes all the way on a range from obligate wetland to UPL for upland. And these values are in your Wisconsin Flora book. If they're not mentioned in the book, then you can default to upland. The range from obligate has to be in the wetland to upland doesn't ever grow in the wetland. It's quite a range here. In the middle is this category called FAC, and that's facultative, meaning that it could go either way. So in the far column here, these are the numeric values. This is one way to use these wetland indicator statuses. The negative values are favoring growth in the wetlands, and the positive values are favoring growth in the uplands on this range from, again, has to be in the wet to has to be in the dry. So facultative right in the middle. Sometimes you find them categorized as FAC-W, that's facultative wetland, so facultative, but more often in the wetlands. FAC-U, facultative, but more often in uplands. And the ones I've grayed out here, I see them a lot less often. Sometimes they're subdivided into this plus and minus for each of the categories. So you could take those values and you get a range of 5 to 0 in the wet and 0 up to 5 in the dry. And one more thing about this categorization scheme is that these wetland indicator statuses are particular to a geographic region. And Wisconsin occupies two of these geographic regions. So one north central and one Midwest shown here on the map. So depending on where you're looking in the state, you might get a little different wetland categorization for a species. Most species have the same or nearly the same wetland categorization, but just bear that in mind. And again, the Wisconsin flora will tell you the wetland value for each of these regions for every species. Just zooming out a little bit more, give you a little better perspective on where these Wisconsin regions fit relative to the rest of the country. So we're in the north central northeast for most of Wisconsin, and then a little bit in this Midwest region. And then here are some other classifications outside of that. And depending on where you are, if you're in the United States, you can maybe find yourself on this map. And I'll direct you from here over to this resource. This is the USDA, United States Department of Agriculture. They're kind of the repository for this wetland categorization system. And there you can go, you can look up your species, and it'll tell you the wetland classification. This is one, just an example, that is always listed as an obligate wetland plant. So it doesn't really matter what region you're in. It's just a characteristic of the species that it is a wetland plant, the tufted loosestrife. So also an illustration of the wetland categorization system. What I've done here for the next 3 slides is I took the species that are listed as most characteristic of these prairie types, dry, mesic, and wet prairie, and we did just a summary wetland categorization of them, just to take an average wetness wetland value for each one. So these species, almost everybody in the dry prairie habitat is listed as UPL for upland. 2 of them are facultative upland, so could be in wetland, but more often in upland. And so these are positive values all around, and the average, the mean of all those is 4.6. So pretty close to 0.5, which is the maximum of the scale of most upland. Looking at the mesic prairie, still mostly positive values, so mostly upland, and then a couple that are facultative. And that brings the average down a little bit, 3.3. And then over here to wet prairie. And now we're getting a whole bunch that are in here as the obligate plants, bringing our value down to mostly negative 1.7. So this is a habitat. In this case, you would, if you took this group of species and you found them in your habitat and you got this average wetland number, this would tell you you're probably in a wetland or habitat that counts as a wetland, and could have some big implications for land management there. All right, our last kinds of values we're going to get are based on this coefficient of conservatism. And this is a value that you can get for species. This is a value that's been developed independently in different parts of the country. So there's a set of C values, these coefficients of conservatism for Wisconsin species that have been developed by Wisconsin ecologists. And the range for the C value runs from 0 to 10. And it's basically an estimate of how likely you are to find that species in a pristine natural habitat. So we're facing a world now where lots of the habitats you run into have been modified by people, whether agricultural or urban, anything else, waste areas, dumping grounds, places where people have dug into the ground, who knows. But basically there are species that really need one of these long established, pristine, never been plowed, never been logged, for example, habitats. And some species, if they have a really high C value, that's the only place you find them is in more of a pristine habitat. So I got a couple of examples here showing different species with different ranges of C value and some estimates of what you can get for your calculations based on those habitats. So on the left here, I've got a habitat that has 3 introduced species. And the introduced species don't actually have a C value. Some people treat them as a 0, but it's sort of, I guess, possible that you could have a non-native species that still only grows in particular habitats. Uh, by and large, you would have an effect a lot like this, where you sure have some introduced species, but among the introduced species would also be some native species that have pretty low coefficients of conservatism. So our native species here, Verbena bracteata, Polygonum avicularia, these have zeros. So very likely to be in places that are modified by people. They're still native plants. And that brings our average down. If we take these 4 native species in this category, 3 zeros and a 2, the average of that comes out to a 0.5, again on this scale from 0 to 10. Here's a wetland habitat that's got some species and a few species that are a lot higher in this coefficient of conservatism. So areas that are, or species that are more often found in areas that are not modified by people is 8s, and 7s. So the average here coming out to 5.4, even though there's one introduced species, overall this is lots of native species and a good number of species that are only found in pristine habitats. An extension of this C value calculation is another value called the floristic quality index. And that takes the C value average for the species you're counting and weights it by basically by the number of species. So incorporates the likelihood that a species grows in a pristine habitat, incorporates that with the number of species overall. So it's sort of a diversity times kind of quality measurement. So I have 2 lists here and they have the same number of species, but you might encounter different numbers of species. Again, these pristine habitats, we kind of expect them to have more species, greater diversity, and that might favor larger values on the floristic quality index in something that's more of a pristine habitat. But here we've got 8 species in each one, which gives us 0.5 times that square root of 8, 1.41, and over here, 15.3.